In the previous video, we have seen different type of literals like integer, float, bool, complex and string. Now we will learn few more things about literals. The integer literals, only integer literals, can be represented in different number systems. So here I have the list of number systems. You can see here there is a table showing number systems. This is a decimal number system, binary number system, octal and hexadecimal number system. I'll explain you about this table. But before that, let me tell you one thing. See, these type of literals which can be mentioned in different number system is useful for those programmers who are familiar with number systems. Alright. If you are not familiar with number system, you can skip the topic also. It's not important for you. The topic is not much important. You can mention the literal already you have learned it in the previous lecture. Right? And if you're familiar with number system, then you can follow this lecture. Alright? And if you want to learn about number system, then you have to take the help of Google. So now I'll explain the table, then I'll show you how we can use different number system for representing integer type literals. Let us see. See, this is the decimal number system. In decimal number system, we use the digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the digits ends here. So total digits are 10 digits. These are 10 digits. So the decimal number system is also called as base 10. This is also called as base 10. Right? So the digits ends at 9, 0 to 9. Total 10 digits are there. Right? And after that, we use 2 digits. Means we increase the digits. Then we start with 10, 11, 12, 13, 15. Then we make it as 20, then 2122, then 30, 3122. Then when we reach last, like 99, then we start using 3 digits, 100. So that's how we increase the digits once the figures are completed, exhausted with the figures, right? Now similarly, we have binary number system which contains only 2 digits. So that's why this is also called as base 2. Binary number system is called as base 2. So we have 2 digits, 0 and 1. The next we write 10. This is not 10. This is not 10. The value of 10 is 2. So that is the reason I have kept it in the table. In terms of decimal, 10 in binary is nothing but 2. Then 11 in binary is nothing but 3. So now 11 means again it is filled. So 2 digits are filled. So we'll move to 3 digits. 100, that is 4. So I have written the equivalent binary numbers for this decimal values, right? So in decimal it is 9, in the binary it is 1001. Now let us come to octal. In octal number system, the digits are 0 to 7. Total digits are 8. So this is also called as base 8. And once that digits are over, we start using 2 digits like 10, 11, 12. And lastly 17. Then after this we will be using 20. And equivalent decimal number you can see in a decimal when you have 10, so in octal it will be 12. Don't read it as 12, read it as 12. And in binary it is 1010. 10 means 1010. Alright. Then coming to hexadecimal, there are 16 digits used in hexadecimal. 0 to 9. Then after that English alphabets are also used, A to F. So total these are 16. So this is also called as base 16. We use decimal number system in our daily life. We use this number system in our daily life, right? So in this, when you write 10, this is value 10 and it is equal to A in hexadecimal. So that's it. I just made you familiar with the number system. Now let us use these number system for defining our integer literal. Alright. Now let us take a variable A and I want to store the value 10 in that variable. So in decimal number system, when I am using decimal number system, I can write a literal 10. If I want to use binary number system, so I should write what? 1010 for 10. So I will write 0B, 0, this is 0, right? This is 0B and 1010. This B can be in small letter or capital letter also. So this will become 1. So the value of A will be 10. Right? 1010 will be 10. So the decimal value 10 will be stored in this one. Though we are writing a number in binary number system, but what will be stored in A? 10 will be stored in A. So object with value 10, integer type 10 will be created, and A will be referring to it, holding to it. So this is how it will look like, whether you write 10 or whether you write 0B1010. Alright, whichever one you are comfortable, you can use it. So if you are familiar with this, you can use it. Otherwise you can write 10. Alright. Now next, let us use octal. So what is equivalent to 10 in octal? So it is 1, 2. So how to write octal? 0, this is 0, and this is O, letter O, right? This is letter O, this is not 0. 1, 2. So 0 you have to write, you have to start with 0, and you have to use a initial for this number system, B for binary, O for octal, then you can write on the number. Alright. Now next, hexadecimal. A assign, so if I want to store, I am using the same variable name, okay, A assign. I want to store hexadecimal 10 in the form of hexadecimal. I want to store 10, that is A. So this is 0x. So it is not H, it is not H, it is X. We use X. And you can write X in lowercase also, uppercase also. A. So what will be stored in this variable A? Same thing, 10 will be stored. So the same value 10 can be written in decimal form like this. This is the decimal number system, and this is in the form of binary number system, and this is in the form of octal number system, and this is in the form of hexadecimal number system. So you can use different number system for representing your literals, right? These literals are the constant values that are used in the program. Now one more thing, I'll write something like this. A assign 0B, binary number system contains only digits 0 and 1, but I will write 125. This will be an error because 2 and 5 are not the digits in binary number system. Binary number system is having only 2 digits. So remember that when you are forming a number, you have to use only those digits that are available in that number system. Right? Decimal number system is having digits 0 to 9. Hexadecimal is having 0 to 9, then A to F. Octal is 0 to 7 only. Binary 0 and 1 only. Alright. So for integer type values, integer type variables, you can use this, any of these number system. Now let us move further. Is it possible that I will give a float value using other number system? Like F assign, I want to give 0B 111 dot 0B11. No, you cannot use these number system literals for float. This is not allowed. For float, it will not work. Alright, so you cannot say anything like this. Even you can't say 111.11. No, this is also not allowed. So these are useful only for integer literals. They are not useful for float type literals. Alright, that's it. Now let us come to complex number. I want to write 5 plus 6j. Can I write this in binary? Let us try. C assign 5. What is 5 in binary form? 5 in binary form is 101. 101 you can see here. Right. So can I write 0B101? Then this 6j as it is I will write. Yes, this is allowed. So if you are using number system in complex number, then you can use the other number system only for the real part. You cannot use it for imaginary part. You cannot write this in other number system. You have to give it in decimal number system only. Alright. So that's all about defining literals in other number systems. So I'll tell you once again, you can use this if you are familiar with the number system, then only you require this. Otherwise you don't require these type of literals. Let me show you the demonstration for these. So just once you can practice it, okay? So at least you know that there is something like this, right? So if at all you require in future, you can spend some time and learning about number system and use them in your project if at all, if it is required in your project. Let me give you demonstration for this one. I will store 10 in a variable. If I say print A, just like you say A, it will print value of A, right? In the shell. Now I will store a binary number 1010. Now let us say A, it will print 10 only because 1010 is nothing but 10, right? It will not show you 1010. While giving the value, we have used binary number system, but what is stored in A? 10 is stored in A. Now I will use hexadecimal system 0xa and print A. It is 10 again. Alright. Now for float, can I use 0b binary 111.111? No, invalid syntax. For float numbers, you cannot use other number system. Let us say complex numbers. 5 plus, okay, I'll give 4 plus 6j. Complex number is taken. Now C assign 0b101. This is binary 5 plus 6j. Yes, it is working. 5 plus 6j. It is showing 5 plus 6j. Now let me try C assign 5 plus 0b110. This is for 6. 110 is for 6. No, invalid syntax. So for the imaginary part, you cannot use this other number system. Only for real part, you can use this other number systems. Alright. Likewise, I'll show you one more thing. I want to take the price of something as input. So I'll give the input, enter price. Okay. A value, just a value. I wrote the variable name as price. Now, can I enter a number now from the keyboard in other number system? Will it work? Let us check. Enter price. I am going to enter the value. So the value I am going to enter is 0b101, means 5. So let us see whether it works. Now, if I print price, if I type price, yeah, it has taken. But it has not taken 5. It has taken 0b101 in the form of a string. It has taken in the form of a string. No, I want it as integer 5. So let me show you. Now here, I will write price assign. I will typecast it as integer. Then I will write input and I say enter price. Okay. So whatever the input that we will be getting will be typecasted with as integer. Okay. This typecasting we will see later on. Just I am using it. Okay. Just see the demonstration. And I am going to take that value as base 2 because I am going to enter a binary form. Now I will enter 0b101. I am entering 5 in binary form. Let us print price and see, yes, it has taken 5. So yes, from the keyboard also you can use or read data in other number systems, right? Not just the literal, you can read them from the keyboard also, but that should be typecasted as integer with proper base. I am entering binary type, so it should be base 2 only. If I am using hexadecimal, then it should be base 16. Alright, so even from the keyboard you can enter a number in other number system. So instead of entering 5, I have entered 0b101 and it is storing 5. So that's all in this lecture. We have learned about defining literals in different number systems. Alright, just you can practice the things what I have shown you once. This is just for knowing that we can define literals in other number system also. That's all. Alright, that's all in this lecture.